All right, so the second problem that we have in our notes today is this limiting reactant problem. And you're given the chemical equation of what's going on. It says how many grams of nitrogen gas should be produced. So right away I know that this is my B. I'm trying to figure out how many grams of the nitrogen gas are going to be made. You're being told that water is also a product. And this time, if you remember this from last year, we have 100 grams of N2H4, which is nitrazine. And we also have 200 grams of dinitrogen tetroxide. And it looks like we have two A's here, and it's because we do. You're trying to see which ingredient or which reactant is going to run out first before you could get to the grams. So we actually have to carry out two stoichiometry problems, something really similar to what we did up there, except we do two setups, and our goal is just to get it to grams of nitrogen gas. And basically, whichever we have less of, that's going to tell you which reactant is going to limit how much product we're going to be getting from the reaction. So I'm going to carry it out with this one first. We have 100 grams of 2H4. Okay. And the setup here is you want grams molar mass over 1 mole. Okay, and then here you know you're doing the mole to mole ratio. And I'm trying to get it to moles of N2. And then finally 1 mole of N2, and we need grams of N2 here on top. So I'm just going to go in and fill in the numbers for the molar mass right here. We're going to be using our nitrogen, so 14.007 times 2 plus 1.008 times 4. And with the molar mass, we get 32.046 here. When we're doing the mole-to-mole switch, these numbers, remember, come from the coefficients of the equation. I have 3 moles of nitrogen gas, and I have 2 moles of N2H4. And then over here for our molar mass of N2, it's 28.014. Okay, so basically to solve, we're going to multiply everything across 100 times 3 times 28.014, and we're going to divide that by 32.046 times 2. I am going to round this to 4 sig figs, so I got 131.1 grams of N2. Okay, and we're going to do the exact same setup, except this time we're going to start with dinitrogen tetroxide here, and we're going to get up to our B, which is just nitrogen gas. This time we have 200 grams of N2O4. Same thing, so we have 1 mole here, and we have grams here, which I'll fill in. And then dimensional analysis tells me I need moles of N2O4 on the bottom. I'm trying to convert it to moles of N2. And then I have 1 mole of N2 on top. And I know the molar mass of this already because I got it before. Okay, so it'll look like this, and we're just going to go ahead and fill in the rest. The molar mass of N2O4 is 14.007 times 2 plus 16 times 4 from the oxygens. So I got 92.014. And the moles of N2, we have 3 moles of N2, and the N2O4 is 1. Okay, and we're going to just multiply and divide. So 200 times 3 times 28.014, and we're going to divide that by 92.014. And with 4 sig figs, we get 182.7 grams of N2. Okay, so here you could tell between this and this, I have less nitrogen gas that's produced here from the 100 grams of the N2H4. So this indicates to us that the N2H4 right here, this is actually our limiting reactant. This compound runs out first. Even though I have 100 grams and I have 200 grams over here, I don't have enough of this to continue reacting with how much I have right here. So the max amount of nitrogen gas that we can produce would be 131.1 1 grams of nitrogen. And the rest of this part down here, you're going to be filling out in the PowerPoints. You're going to go back to that.